View of good old-fashioned factoring and foiling and things like that. When you have junk times junk, x plus 4 times x minus 6, what do you have to do to simplify that out? You foil it out. Very good. So when you foil that out, what does that stand for?
First, inner, or outer, inner, last.
And then it makes a little face. His name is Billy. Billy Rhino.
Billy's got a big old head. All right, so you foil that out, you get x squared minus 6x plus 4x minus 24. Combine your like terms, you wind up with x squared minus 2x minus 24. Reason why I bring that up is because there will be times that we will distribute. You're going to get to quadratics. You have to remember how to go backwards and forwards. We've mentioned this before. The skills of algebra, whether it be factoring and foiling and all that kind of stuff, it never goes away. We just start using it in different diagrams. Quite honestly, we start using it in different diagrams and going from that. What is x plus 5 quantity squared? You just killed a puppy. Thank you. There. You guys, if you write this, you killed a puppy.
Sorry.
The puppy dies every time you do that.
No, isn't it? Is it x squared and you add? Yes, you got a shortcut.
That's right. Like Mr. Pitt said, when you see what I like to call it junk squared, whenever you have junk squared, it means it's junk times junk. Just write it out twice, and that's what you were getting at too, Hannah. Write it out, and what did you say it was, Brandon? You said it was x squared plus what? 10x, very good. Very good. All right. There's many, and you were using a shortcut on that, which is fine. Or just write it out in combined terms. You're going to get to the same result. Okay? Just wanted to quickly remind you guys of what that meant. Please don't kill puppies. They're cute. What about cats? All right. I see how it is. Never been a big fan of cats. Factoring. Again, we get to the point where we will factor again as well. You will see this. The way that I like to set up factoring is I always go back to the old standard algorithmic way of doing it. It's the old school way of doing it. And it's more of a number sense style. And it will always work. It's just a matter of you have to know a little bit about these things called times tables. I don't know, call me crazy. So what I'm doing, thanks. What I'm doing here is what times what multiplies to 40, but it adds to negative 13. So you need two numbers that multiply to 40, but yet they add to equal negative 8. Very good, very good. Now, one of the things you should pick up on right away is that noticing that last term is positive. If the last term is positive, that means when you FOIL things out, that means your last two numbers had to be the same sign. They either both have to be positive or both have to be negative. Because positive is positive, negative times negative is also positive. What Hannah figured out as soon as she said the 8 and 5, and she immediately said, oh, it's got to be negative, was that the middle term was minus. So that means you multiply together negative 8 times negative 5, and you add them together to get negative 13. So your, what we call terms, the terms are the things that are in the parentheses, is x minus 8 and x minus 5. There is a huge importance to being able to decipher between what are called terms and what are called zeros. Terms are in parentheses. Zeros are when you set that equal to 0, you solve each individual part. You will see that also in this whole circle thing. My zeros of this would be, what makes this 0? 8. What makes that 0? 5. When you did this last year, you were working with what's called a parabola. this parabola crossed the x-axis at 8 and 5, and it was up like a cup. That's what you did last year. You're finding the two values that create zeros. When you create a zero, it's a zero. That means where did you cross the x-axis? This all comes back around and get it round. That was it. That was inadvertent pun.
All right, dollars.
Which means we can do something like this. We had an example like this yesterday. Where we had a tangent segment, and then it created the right triangle. And excuse me. And Justin brought up to us right away. Hey, bozos! You guys all got mad. I'm like yelling like, "Hey, bozos!" You guys are like, "Oh crap! What I do? I put my computer down." Yes. You had to use the Pythagorean theorem. All right. Now, the reason that I wanted to remind you guys of this stuff is that notice where your variable is located. It's in the circle. The variable is being played by the role of a.
What is that called?
What is that called from the center to the side? It's a radius. So the radius, we're trying to solve for the radius of this problem, either part there. Now, if you think about it, this section here is our hypotenuse because it's across from the right angle. Are we okay with that?
Yes.
So I have to set it up algebraically. We have x squared plus 63 squared is going to equal, well, what's this whole segment?
49.
No, the whole segment.
The whole thing. 49 plus x. Very good. And this is why I wanted to remind you guys about this whole junk squared. Okay? I wanted to remind you guys about this idea of junk squared because you will have to do this quite often. Don't kill puppies. You kill a puppy, the whole problem goes away and nothing works. So what you would do, you have x squared plus, I don't know what 63 squared is, but I know it ends in a 9.
392.
And then I FOIL out the next one. Now, there's a shortcut that you can do when you have junk squares. If you square the first term, square the last term, I bet you it ends in a 1.
Yeah.
0.401.
Now, to get the middle term, anytime you do junk squared, just double that number and put the x next to it. So what's 49 times 2?
98.
That's the shortcut. Could you go ahead and write out x plus 49, and FOIL it all out and get the same answer?
Yeah.
Absolutely. Okay. Now, if you take a look at what we have now, we have variables on both sides of the equation. When you have x squared terms, think back to algebra from last year, you want to move them first. What happens when you have x squared on both sides? They just go away, don't they? Because if I subtract x squared to the right, bless you, or to the left, it becomes 0. If I take x squared to the right, it becomes 0. Since they have the same, since they have the exact same coefficient, the x squared term drops. And you're then you're at 3969 is 98x plus 2401. Two-step equation now. The only thing that was only shenanigans and trickery thrown into this problem was the fact that you had to FOIL something to start with. Subtract your 2401. And then divide out by the 98. I have no idea, but it's 16. I was just about to say it probably ends in a 6.
16.
Pretty sure. Well, I knew you had to do 6 times 8 to get an 8. And there's your radius. That's the kind of things that we're going to do. Okay? What's the next point? And notice I gave you the big number 1 first. Because why start little? Might as well scare you to start with, right?
A squared plus C squared, right? Goes up the right angle, R looks like it's gonna be 9.
Whatever, man. We'll just talk about it. Do that.
It looks like it was cut in half between 9 and R. On the hypotenuse. Sorry.
I have my moments. Which one's your radius?
Oh.
No, I didn't mean radius. Which one's the hypotenuse? Excuse me. You're right. R is the radius. Thank you. R, it's not 9R. No, it's not R9. So you get R squared plus 15 squared is R plus 9 squared. Is it okay if you do 9 plus R, R plus 9? Doesn't matter. FOIL all of that out. We have R squared, oops, plus 225, R squared, and an 81, I believe. And notice right away what happens to the R squareds on both sides of the equation. Square it, double it. It works. If it's even, if it's R minus 4, it's the same idea. Square it, square it, minus it.
That's true. Does it work or does it need?
No, when you have 3 of them, you actually have to FOIL it out all because there's 3 parts to it. It won't work that way. There's a rule about if this is cubed, there's a shortcut, but you'll worry about that next year.
And what's the short?
We'll worry about it later. In this case, everybody okay? R squareds go away.
Yes.
Okay. Subtract the 81. What is that? 144.
Yes.
Yep.
And divide it out. What do you get?
R equals 8.
That's what we're doing today.
Okay.
Oh, thank you. On this one here, I'm trying to figure out there wasn't all of this stuff. He did a chunk of this kind of same thing yesterday. I thank you for all the love you bring. I recall December park and fall. How you told, what a mess I must have done to shame. Ooh, done. Do that substitute paper, please, because when you get into the algebra stuff, you won't have room.
Get that right, King. What up?
All right?
Got that what? No, boy, I don't have anywhere to place it outside.
Because the front page is basically what you guys did yesterday out of the book. Okay?
Sorry.
And I'm sorry. You know what? This happened right now. It happens. I mean, it was like 5 times 4. You wrote down 7. Putting it everything right, and something maybe substituted in, correct? I can't remember right now the wrong number. Yes, ma'am. Yes, but I don't know how far we're gonna get quite yet. I'll have it posted online, and then that way you can just, if there's a work stream like that, I'll have everything posted, you can just look on it and just go from there. Because we'll probably start a little bit of 10.2, which is dealing with what are called central angles.